Hello everyone, Mr. Minnick's my name, math is my game. This particular group of students, it's very rare that they have a lesson where I record it live with them. So anyway, there's a couple of their classmates that are on a field trip, and they actually have another classmate that they don't know about who's not even, well, they do know about. It's not even in the same class, so shout out to Jack Norris if he's watching. And so today, the title of the lesson, 4-7, we went a little bit out of sequence. We went to 4-8, which talked about complex numbers. Now we're back to the quadratic formula. For the record, Mr. Minnick hates the quadratic formula. That's going to be a Kahoot question, too. For the record, I can't stand the quadratic formula. There's some good things about it. There's something new that we're going to learn about it today that you probably didn't know. Maybe you did, and you could have forgotten it. I don't know. I'm going to be opening up Microsoft Word to show you something about the one word. I don't know if anybody made it that far in the title. Did anybody make it to the learning objectives yet? If you look at the second learning objective, it says that part of what you're going to be doing today is determining how many solutions a quadratic equation has by using something special. What's that word? The discriminant. Anybody ever hear that? It's a fancy word that Microsoft Word doesn't even know is a word. I know you don't believe me, so that's why I got Microsoft Word out. So let me see if I can zoom in. View, zoom. We'll go to 200%, make it nice and big for the whole world to see. We'll try to. I don't know about the whole world. People that don't read English probably can't see it. So anyway, I'm going to type the word discriminant, D-I-S-C-R-I-M-I-N-A-N-T, discriminant. And, oh, it didn't underline it. Maybe it does now. It made a liar out of me. Let's see, what's this magic thing? Undo. What do I want to do spell check. Review, spelling and grammar. Okay, it does recognize it as a word. In the past, it must have updated in the last 5 years. It never used to recognize it as a word. So, all right, so I stand corrected. I guess I'll have to change that question in Kahoot. Anyway, let's look at it. Here we go. The quadratic formula. Quadratic formula. I'll never forget when Mr. Englehart taught Algebra I, he would make his students wait in the hallway, and one by one they'd have to recite it to be able to get into class that day, the next day. So anyway, of course, the quadratic formula goes x is equal to the opposite of b plus or minus the square root of b squared, take away 4 times a times c. And then all that, the negative b, the plus or minus, everything is going to be over the quantity of 2a. That's the quadratic formula. And what you need to know about that, what you need to realize about that, that's true whenever you have a quadratic equation in standard form. If the quadratic equation's not in standard form, well then you're probably going to misidentify the a, the b, and the c values. So far so good? Awesome. So we mentioned this word, the discriminant. The discriminant. And actually, Microsoft Word does recognize it as a word now. The discriminant, all that is that. It's just the radicand. It's the radicand of the quadratic formula. So the discriminant is the radicand. When I say radicand, I mean all the stuff under the radical. It's the radicand of the quadratic formula. That's all the discriminant is. It's just that stuff under the square root. What it does is it tells us how many answers our equation has. Now, most of you probably are aware that quadratic equations have 2 answers because the exponent's 2. So we need to talk about some special ones, and we'll look at that in example 1. So here we go, example 1. Solve 4x squared minus 4x plus 1 equals 0. Using the quadratic formulae. Notice the directions clearly and explicitly say, yeah, we want you to use the quadratic formula. So we probably ought to identify A and B and C and plug into the formula. So let's see what that looks like. What's our A value going to be? Anybody? 4, good. And our B is -4, and our C is 1. So according to this formula, x is going to equal the opposite of b, so that's minus 4, plus or minus the square root of b squared. So -4 squared minus 4 times a times c, and that's all over 2a. So I purposely left out some parentheses. Probably most notably right here, this -4, the quantity squared. That's where everybody screws this up in Algebra 1. Everybody screws that up because they don't put parentheses around that -4, and when they square that, they end up with a negative sometimes. That term's always going to be positive, right? Whether your b value is positive or negative, when you square the b, it's all that item that's left is always going to be positive. So that's one place where people screw this up. Remember, for the record, I said I hate the quadratic formula. I hate it because there's a lot of places to screw it up. That's one of them. Next place people screw this up is when they multiply 4 times a times c. Now in this case, my a and c are positive, but if a and c are negative, some people screw up a negative times a negative times a negative. If you have 3 negatives, the whole product is going to be negative, right? So you got to watch the signs there. And then in the bottom, it's 2 times a or 2 times 4. So there's a lot of places where people can screw this up, like -4. Doesn't that become +4 then? Cool. All right. So evaluating this is going to take up a lot of space on my paper. That's going to be +4 plus or minus the square root of 16 minus 16, and that's all over 8. 16 minus 16. Huh. 16 minus 16, isn't that 0? So I get 4 plus or minus the square root of 0 all over 8. So there's something very noteworthy that happens here. My discriminant is equal to 0. And one of the objectives of this lesson is for you to understand what happens when the discriminant equals 0, when it's bigger than 0, and when it's smaller than 0. So when it equals 0, let's look at the rest of our answer. The rest of our answer, I'm going to get a white marker out and kind of white out this square root of 0, because that goes away, doesn't it? So my only answer is 4 over 8, which we know, I hope we know by now, we need to reduce fractions if they reduce. So what's it going to be? 1/2. So the only answer is 1/2. So in the event that my discriminant is 0, we ended up with one real solution. Huh. It's kind of weird. Yeah. That's the answer. It's 1/2, and there's just one real answer. So I'm glad you asked. Sometimes you're not going to be asked to solve it. Sometimes you're going to be asked how many answers does it have, or how many solutions does it have. Sometimes you're going to be asked to solve it. Now this one, the solution is 1/2, but if they're asking you something related to the discriminant, they'll say, use the discriminant and determine how many answers this has. Well, this only has one real solution. But this phrase right here, one real solution, that can be stated in several different ways. Because how many answers do quadratic equations really have? 2. So our answer is not just 1/2. If we think about our solution set, there's got to be 2 things in it. And 1/2 is definitely one of them. What else is the other one? Not 0. Maybe we should take a trip down memory lane. This is why Mr. Minnick likes factoring as opposed to the quadratic formula. Mr. Minnick hates the quadratic formula because it doesn't show you all the pieces of the puzzles all the time. We looked at 4x squared minus 4x plus 1 equals 0, right? At this point in time, everybody should be able to recognize what that is. And if you can't, you might have to go in the back of the room and sit and think about life for a while. Anybody know what it is? Perfect square trinomial, right? It's a psst, and we know that a psst factors down into some BS. So it's going to factor into a binomial squared of what? 2x minus 1. And if we factor that, we get 2x minus 1 times 2x minus 1 equals 0. And so our solution set has 1/2 in it. And the other solution is also 1/2. So the interesting thing is when we do this, one real solution has a weird implication. One real solution is the same thing as saying there's one unique solution. There's one unique solution. It's the same thing as saying that. It's the same thing as saying the solution is repeated. The solution is repeated. So whatever your answer is, it happens twice, as Eminem would say, or twice, as the rest of the English-speaking population would say. What do we think? Got him? Let's look at the implication of this from a graphing perspective. If we look at example 1 again from a graphing perspective, suppose we had this function f of x equals 4x squared minus 4x plus 1. I don't need a super fancy graph. I just need some axes. I know it has an x-intercept of 1/2 and 1/2. So if this is 1, this is 1. The x-intercept is 1/2. The y-intercept is 1, and this graph goes like this. It goes whoop, whoop. So the deal is what happens down there. What happens down there is that the graph turns around. The graph turns around. And we're going to study that in great lengths in chapter 5 when we get to polynomials. Okay? Questions, comments, concerns, short debate so far? Okay. Well, let's look at example 2. Example 2. Solve with the quadratic formula. X squared minus 4x is equal to negative 14. So remember, we got to identify A, B, and C properly. Our A is clearly 1. Our B is clearly negative 4. Our C value is not so clear. If we get the thing in the right form, I guess it's going to be x squared minus 4x. Is it plus 14 then? So our C is 14. So our C is 14. So our C is 14. So the quadratic formula, here it goes. X equals minus 4 plus or minus. Is it always going to be minus 4? No, it just happens to work out the way I picked my first 2 examples. Negative 4 squared minus 4 times 1 times 14 all over 2 times 1. All right. Huh. Wow. So minus 4, I think we know, is positive 4. Plus or minus the square root of what happens when I square the negative 4 quantity squared? It's positive. It's going to be 16. So 16. A lot of people have a hard time multiplying by 4. It's real easy. Just double and double again. Everybody knows 14 times 2, I hope. It's 28. Let's double 28. What do we get? 56, right? 56. Okay, so that's 16 minus 56, and then it's all over 2. See, this is why I don't like this one, because, look, I already took up about 4 lines on my notebook paper, right? I could have completed the square in like 2 lines and had my answer 25 seconds ago. Anyway. So this ends up equaling 4 plus or minus the square root of, is that going to be negative 40? Negative 40, and then that's over 2. So one thing that's noteworthy on this one, Remember, we've been talking about this discriminant thing. In this case, my discriminant is less than 0. When my discriminant's negative, if you were in Algebra 1, you get to write an RS. Or actually in Algebra 1, you just write NS, right? No solution. You draw that null set sign. But we had Chapter 4, Section 8. We could take this a step further. We could use Mrs. Accordino. We're going to pop an I out. So this is going to be 4 plus or minus. I like thought bubbles. In my thought bubble, I'm thinking to myself, what the heck is the square root of negative 40? Well, I know it's the square root of negative 1 times the square root of 4 times the square root of 10. So an I is going to pop out, a 2 is going to pop out, and a rad 10 is going to be left, right? So all this ends up becoming 2I rad 10. And the whole thing is still over 2. Now, it's kind of unfortunate that we haven't studied Chapter 8 yet. I know I keep saying that over and over and over again. But in Chapter 8, we study how to simplify something like this. And when you simplify something like this, what you got to understand is that 4 halves can be simplified, as well as this 2I over 2 can also be simplified. That 2 in the bottom will actually cross-cancel both the 4 up top and the 2 up top. So the 2 in the bottom becomes a 1, the 4 becomes a 2, the 2 becomes a 1, and our final answer here then, well, it's not our final, it's not the best way to write it, but our answer looks like it's going to be 2 plus or minus 1I, or I, times the square root of 10. And I guess that is it. That's good. That's good. That's all right like that. 2 plus or minus I times the square root of 10. So Mr. Minnick hates the quadratic formula because it's clunky. Anybody ever drive a car or truck where you have to remember to do like 7 different things to drive it? Like the seatbelt doesn't latch, so you have to push the seatbelt in and duct tape it in before you can drive it. And the key doesn't stay in the ignition, so you got to maybe put some bubble gum on the key to keep it in the ignition. Well, you don't want to do that. But anyway, I used to drive cars like that, old beat up cars, junkers. And it's no fun driving a clunker. Look at that. That's like 42 pages. That's a whole sheet of notebook paper for one stupid problem, isn't it? Let's look at that one with completing the square. Let's just do them side by side, just for the heck of it. Example 2, solve. We had x squared minus 4x, and we had that equal to what? Negative 14? Just a little trip down memory lane. Completing the square, we're going to add how much? Half of negative 4 is negative 2 the quantity squared, and on the right we're going to add 4. So on the left we get the quantity x minus 2 squared. That's equal to negative 10. We take a square root, x minus 2 equals plus or minus I rad 10, and x equals 2 plus or minus I rad 10. I don't know how you feel, but I think that's a lot more compact, quick than the quadratic formula. But the cool thing about the quadratic formula is the quadratic formula, with this idea of the discriminant, it's going to give us a quick indication of what our answer is going to be, if it's going to have imaginary numbers in it or not. So I guess we better complete this phrase. When the discriminant's negative, what can we say about our answers? When the discriminant's negative, what can we say about our answers? We are going to have 2 answers, but what kind of answers are they? They're non-real, they're imaginary. We have two imaginary solutions. 2 imaginary solutions. Okay? So if our discriminant's negative, we're going to have 2 answers, and they're going to be imaginary. We're going to have to pop an I out. From a graphing perspective, if we think about this from a graphing perspective, example 2 again, graphed. We had x squared minus 4x. I guess it'd be plus 14 equals 0. Actually, it would be y equals. If we graph this thing, its vertex is going to be 210, right? I don't know if you remember this. Y equals x squared minus 4x plus 14. We subtract negative 2 squared, so we minus 4. So our vertex would be 210, right? So our vertex is 210. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vertex is 210. It's a parabola that starts there, and it opens up. What x-intercepts does it have? It doesn't. It doesn't. So the cool thing is the discriminant tells us quickly if we're going to have imaginary answers, but so does graphing, for that matter, doesn't it? So each and every way we solve quadratic equations, whether it's a quadratic formula, whether it's graphing, whether it's factoring, whether it's completing the square, each way has its advantages and disadvantages. And I think it would be prudent for us to spend a whole entire day talking about that maybe next week. What are the advantages and disadvantages of each method? Factoring is really fast if it factors. Graphing shows us if we're going to have imaginary answers or not pretty quickly, if it graphs easily, if we can put it into vertex form quickly. So, all right, let's look at example 3 then. Example 3, solve with the quadratic formula. I'm going to use my calculator, make sure I get one. You know what's coming next. The discriminant's going to have to be positive on this last one. And we're almost done. We're just going to look at one more. Oh, that's a good one. 5x squared plus 30x. Oh, was it plus 30x? No, it's not going to be plus 30x. It's going to be plus 32x. 5x squared plus 32x. Y equals 5x squared plus 32x plus 12. Oh, it's not. Oh, dang it! It's supposed to not y equals though. It's equals 0. Sorry, my bad. That's a neck. There we go. Well, this is nice. All our A's and our B's and our C's are all positive. That's awesome. I love it when they're like that. Positives are great to work with. X equals negative B plus or minus square. Oh my gosh. Are you for real? I got to square 32? Are you kidding me? No. Minus 4 times 5 times 12. That's all over 2 times 5. Ah! Dang it. That's negative 32 plus or minus the square root. It's going to be over 900. 30 plus 2 times 30 plus 2. That's 960. 60 more and 4 more. That's 960 and 60. That's 1120. 1124. 1124. 4 times 5 is 20. 20 times 12 is 240. So minus 240. And that's all over 10. Wow. So 1124, 24 minus 240. It's going to be a 4, 12, that's an 8, that's a 10, that's an 8, 884. 884, so that's negative 32 plus or minus the square root of 884. And that's all over 10. Now you know we're not done because we got to find out how 884 breaks down with its radical, because this is varsity math and we got to be able to simplify that radical. Oh man. But in this case, one thing we know for sure is that our discriminant is greater than 0. And our answers, they're both going to be what kind of answers? They're going to be 2 real solutions. It doesn't tell us if they're going to be rational or not. 884, that's not a perfect square, is it? Yeah, question? Did I mess up the numbers? It's 1024? Thank you. Good looking out. It's going to be 1024? Oh, yeah, you're right. Thank you. Awesome. Good looking out. So let's back that thing up. So it's not 1124, it's 1024. Thank you. Appreciate that. So is that going to make that 884 still or 784? 784 then? Okay. So that's going to make that 784. Well, that might be a little bit easier to break down at square. Is that a perfect square? Are you serious? What is it? No way. You got to be kidding me. So this is negative 32 plus or minus 28 all over 10. Is it okay to leave the answer like that? No, we're going to have some spoiled milk. We better take the groceries in the house and put them in the fridge, in the pantry. So this is going to be negative 32 minus 28 over 10. Or it's going to be negative 32 plus 28 all over 10. So that's going to be negative 60 over 10, which is negative 6. Oh my gosh. Our answers are rational. What's that mean we could have used right off the bat? Factoring. Oh gosh. So one of my answers is negative 6. Let's see. Negative 32 plus 28, that's what? Negative 4 over 10. So that's negative 2 over 5. Wow. Boy, do I feel silly. Used the quadratic formula, did all that work, and the thing would have factored. Do we want to look at that one factored for the review's sake, or no? Let's look at it factored just for the sake of the review. Example 3, solve. So it was 5x squared, was it plus 32x in the middle? And then plus 12? And that equals 0. So right off the bat, if you want to know if something factors, you got to do this AC thing. Some people call it the AC method. A times C is going to equal what? 60 here. So we have a plus 60. And we want to know 60's factors that add up to 32. And they show up really quick. 2 and 30. And then we divide by the leading coefficient, which is 5. Which is 5. And 30 over 5 reduces to 6 over 1. So our factorization would be 5x plus 2 and x plus 6. See, that would have been so much faster than having to multiply and multiply wrong and get 1124 instead of 1024. Wow. Wow. So our solution set was what? Negative 6 and 2/5. All right. Well, let's look at one with irrational answers, and then we'll be done. I know I said that's it. We're just about done. I want to look at one if we have some irrational answers just to see how those come into play, and then that'll be it. Okay, something that doesn't factor. Last one. Last one. Solve 4 minus 6x equals 13x squared. Everybody has a different way of putting things in standard form. Some people would bring the 4 and the 6x over with the 13. Some people would bring the 13x squared over. It doesn't matter. If your A, B's, and C's all have the opposite signs as mine, we're still going to get the same answer. How do we want to do this? Bring the 13 over? Or put the other ones over? The other one's over? Okay, so we're going to have the 13x squared where it is. And then how many x's? Plus 6x. And then minus 4? Oh, that's nice working with that many, with 2 positives and a negative, right? Now that's equal to 0. I could put the equal to 0 over here. Same thing, right? That's your reflexive property at work. So let's see. X equals negative 6 plus or minus the square root of 6 squared minus 4 times A times C divided by 2A. Wow. 52 times 4, that's going to be what, 208? So it's going to be negative 6 plus or minus the square root of 36 plus 208. That's all over 26. 36 plus 208, is that 244? So this is negative 6 plus or minus the square root of 244. It's all over 26. Now I know somebody wants to cancel the 6 and the 26. You can, but not yet. You can't do that unless you have a multiple of 2 out here, so we can't cross cancel just yet. But we do need to bust up 244 and see if that breaks down with square roots. It doesn't? Well, I bet it does. It's divisible by 4, isn't it? 1 and 244, 2 and 122, 4 and 61, right? 4 is a perfect square. So this is going to be negative 6 plus or minus, what's the square root of 4? 2. So plus or minus 2 rad 61, and then this is all over 26. And we're almost done, but this is varsity math, and I do expect you to not only put your groceries in the house, but also to do something with the plastic bags and the receipt. And then take the trash out, because the trash is probably full because you emptied all the stuff out of the fridge to make room for the new stuff. Anyway, what I'm getting at is this 26, this 6, and this 2 are all divisible by 2, so we're going to cross cancel that. The 26 is going to turn into a 13, the 6 is going to turn into a 3, the 2 turns into a 1. So our answer is negative 3 plus or minus the square root of 61 all over 13. Now, I know there's people out there that probably don't believe me. They think Mr. Minnick just is making this stuff up because he can't even multiply those. He can't even square that one number. He messed that up. So this is probably wrong too. So let's look. We better look and see. Negative 3 plus or minus rad 61 all over 13. Wow. That was a lot of work. You see why I hate the quadratic formula? I'm not a fan of it. And 3 weeks later, the calculator's loaded. Okay. So that's negative 3 plus rad 61 over 13 and minus. So it's a fraction. Negative 3 minus rad 61. I said rad 61, and it's all over 13. I'm going to go ahead and store that as x. And I want to check to see if it makes my original equation true then. What was my original equation even? I don't even remember now. 4 minus 6x equals 13x squared. 4 minus 6x equals 13x squared. So if that's a true answer, this should return a true statement. Let's see how we did. Okay. All right. Let's go back. See what we did wrong. 13x squared is good. Plus 6x is good. Minus 4 is good. X equals negative 6 plus or minus the square root of 6 squared. Minus 4 times A times C all over 2A. Everything there looks good. Negative 6 plus or minus the square root of 36. Let's see, 4 times 13 is 52, right? 52 times 4 is 400 or 208. 208 plus 36, is that 44? 44? Maybe it is right, and the calculator just isn't interpreting it. What'd you get? 308? When you multiplied what by what? 4. Well, 13 times 4 is 52, right? 52 times 4, there's an 8. Should be 208. All right, maybe we better try it another way. Doc, insert graphs x squared plus 6x. What is it, x squared? Oh, 13x squared. 13x squared plus 6x. Dang it. 13x squared plus what? 6x? And then minus 4? Like that? Okay. So I want to find one of my zeros. Want to find one of my zeros. We saw that one of them is negative 0.83, right? Negative 0.83. So menu, trace, menu, trace, graph trace. Oh, negative 0.83. So why didn't it like that? Was it 4 plus 6 in the beginning? So how come it didn't like it that way, though? Let's try 13x squared. Was it plus 6x? Minus 4. So this should equal 0, which it does. 3 times 10 to the negative 13th, that's 0. What about the other one? What about the, if we change that to a plus? If we change that to a plus, it's 0.37. 0.37. So our other root should be 0.37. And it is. So we're good. We're better than the calculator. Not what was the one? 32 times 32, but on the other, everything else is all right. How do we feel about this, okay? I wouldn't be doing my job if I didn't mention this. You're probably asking yourself, what the heck does that even say? I can't even read it. The writing's so sloppy. So here we go. Discuss the nature of the knots. It shouldn't say knots. And dyslexia didn't strike again. It's not snot either. So just discuss the nature of the roots of that. Anybody know what the heck the question's really asking you to do? Because there's going to be one like that in homework. Yes, if it's real or imaginary. So what's the implication that they want you to find? You don't have to solve the whole thing. The implication is that you're just going to find the b squared minus 4ac, right? That's all you're going to do. So it's going to be negative 6 squared minus 4 times 5 times 1. So that's 36. Is that minus 20? I don't even care that it's 16 or whatever it is. I do care that that's greater than 0. My discriminant's greater than 0. So what do I know about the roots? There's 2 of them, and they're both going to be real. Does that make sense? So if you encounter a question that says, discuss the nature of the roots, hopefully now you'll be prepared to understand. They just want me to find the discriminant and interpret that. If it's 0, there's 1 repeated solution. If the discriminant's positive, there's 2 real ones. If it's negative, there's 2 imaginary ones. And there wouldn't be any x-intercepts on the graph. Got it? Anybody want to give a shout out? I'm going to give a shout out to Austin Lysak if he watches this back. I'm going to give a shout out to Maylee Warren if she watches this back. I'm going to give a shout out to Grace Mills if she watches this back. I'm going to give a shout out to the future Mr. Minnick for being so awesome. Even though he couldn't multiply that one number, we'll let you live this time. See you.
Good.